Okay, we were looking into BGP. In that, we saw next hop behavior. Just to remind you, I have taken the screenshot of one of the slide which explains the next hop peculiar behavior of BGP here. This is the network that we are focusing. 172.30.0.0. This network is advertised to iBGP neighbor, which is router B. And router B will advertise it to router A, which is eBGP neighbor. But when it advertises to A, instead of giving this address as a next hop, it gives this address as the next hop. So in router A, for 172.30.0.0, what will be the next hop? 10.10.10.2. It's not 10.10.10.1.
10.10.10.2.
Yeah. Even though 10.10.10.2 is not neighbor, even though A and C are not neighbor, you will see C address to reach 172.30. The reason is this. If it gives this address as the next hop, then the traffic will go here. How it will go? It will go through the switch. Again, it will come back on the same port, on the same switch, and go to C, which will be a wrong approach, which will be a waste of bandwidth and CPU. So what we learned is BGP is efficient in finding what? The best next hop. The next hop expected is this, but that's not the best one. But normally routing protocols will put the address of its own when it advertises. The advertising router's address will be the next hop. Who is advertising to A? Who is advertising to A? B is advertising.
B.
But B, see, it is efficient, it is clever to say, you don't need to come to me.
Yes.
You can go straight to C. Because it's just a layer 2. We are all in same subnet. 10.10.10.3, 10.10.10.2, 10.10.10.1. We are all in same subnet. So you no need to come to me. You can locally get switched by this layer 2 device. This is something unique in BGP next hop behavior. This is something unique. Yeah, this is what I would like to show you. So let's quickly put the IP addresses on the respective routers. Router 1's loopback is going to have this as an IP address. This is the network that I'm going to advertise in BGP for testing. All the loopback interfaces are only for testing the reachability and the next hop to reach them. Then Actually, it is not 32, it is 16. Only the loopbacks can be 32. All right, and then I'd like to end it and then put this on router 1. Router 1, you are fully loaded. Now, let us finish router 3, then we'll move to router 4. So router 3, it's going to have 3.3.3.3, and on the F00 interface, it is 3 here. That's it. This is going on router 3. Next, I would like to finish router 4 before I come to router 2. You see, router 4 will have loopback 4444, and then here it is 2424. 4. And the mask is 24, so I'll give another 255 here. That's this basic on router 4. Now one last router to configure, which is router 2. To the 2. F01 has got .2 here, and there is another interface 00 that has got 10 10 10 2. That's it. Now after I finish pasting on router 2, we'll get into BGP. Okay, now I'm expecting reachability between the adjacent routers. For example, from R2, if I ping 24 24 24 4, I should ping, and 10 10 0 1, I should ping. The reason is the interface is good. Oh, I put wrong address here. Yeah. Now let me try pinging again. Let me go to router 1 and check. Here also I have added another 10. That should not make any big difference. The difference is I was pinging the wrong address then. So let us change to the original address 10 10 0 1. There was no 10 10 0 1 early. Now I have put 10 10 0 1. It's a mistake I did in Notepad. Similarly, I have to do changes on R3. It's 0 here. Okay, now let me try pinging R1 and R2. 10, 10, 0, 1, it will ping. The reason is same subnet. Likewise, it will ping 0, 2. Okay, now comes the BGP part. We are going to have this in one autonomous system, another one, and then another one. So there are 3 autonomous systems. Yeah. So let me name these autonomous systems. Done. What next is BGP configuration. As we already discussed, between router 2 and router 3 it is eBGP.
Yes.
Between router 1 and 2 is going to be IBGP. And again, between 2 and 3, 2 and 4, there is eBGP. What you don't have is between 2 and 3, you don't have eBGP. This is between R1, R3. All right. So I'm going to go do these things straight on CLI. On R1, router BGP 10, I got an IBGP neighbor 10.10.02. Remote AS the same 10. I got eBGP neighbor 10.10.03. Remote AS is 10.10.03 is in 20.
20.
And I want to advertise the network 1.1.1.mask. Done. Now, this is R1. Let's go to router 3. R3. Router BGP 20. Neighbor 10.10.01. Remote AS is 10. And the network is 3.3.3.3. Mask is done. See, we have a eBGP now. Let us finish R2 and R4, then we'll go verify all together. Router 2, by the way, I want to check pinging once. This ping should go now. Okay. Now, router BGP 10, one IBGP neighbor, another eBGP neighbor, 30, and one network that I want to advertise. Done. Now, router 2 is also done. Let's go to router 4. Before I configure BGP, I would like to check the reachability between between 2 and 4 routers, 24, 24, 24, 2. It is pinging. So now what I can do is I can say router BGP 30 neighbor 24, 24, 24, 2 remote AS 10 network 4.4.4.4 mask. Then all right, it's time to verify. You're going to see that magic. I'll take to router 3. You know where is router 3? Router 3 is down. From here you're going to check. Show IP BGP summary. Do we have neighbor with router 2? No, we don't. Got it there?
Okay.
Router 3 has got only neighbor with router 1. But if you check the networks that it learns, show IP BGP, you can see that it has learned 2222 not from its neighbor, but from another router which is in that same network. Is this neighbor? You see, neighbor is only 10.10.01. But you can see a router which is not a neighbor acting as a next hop for this network. You understood now?
Yes, sir.
This is the next hop behavior. It is good. It is good that it has got this neighbor. If not, it will be unnecessary layer 2 hops. It need to go to router 1 and then to go to router 2, which is not really good. Wait, we advertised this network 4444. I do not know why I'm not able to see it here. Let's troubleshoot. Go to router 4 and check whether we are advertising. Yes, we are advertising. Show IPBGP. We do advertise it. We can see it here. Now I would like to go to router 2 and check whether it learns it. Even this is learning it. And then why it is not giving? It should give. Go to router 3 again and check. What about router 1? Here I can see, listen, this is the secret. Router 1 is not having a valid next hop. Why? eBGP address is carried into IBGP.
Yes,
So what
carried
we
into
need
it.
to do is we need to go to router 2 and say next hop self to router 1. That will make this route valid and best. Only then router 1 can give it to router 2. Sorry, 3. See, router 2 cannot give directly to router 3. It has to go here and then come here because these two are the eBGP neighbors. But when it comes here, it will have the identity of router 2 as the next hop. Let's do it. Go to router 2, router BGP 10, neighbor 10.10.01, next hop self. Clear IPBGP starts off. Whenever you do some changes to the attributes like next hop or any attribute, you have to refresh BGP. Clear IPBGP will do a hard reset, which is a disruptive one. To avoid the disruptiveness, we put soft. And what does the star means? It means all neighbors. Now let us go to router 1. You can see 4444 is having a valid next hop. Now go to router 3 and check. You will find 4444 with router 2's address, and this is originating from autonomous system 30 and it is coming via 10. So I'll be able to ping 4.4.4.4 with a source of 3.3.3.3. I can also ping 2.2.2.2 from the source of 3.3.3.3. I can also ping 1.1.1.1. Show IP BGP. So even though 10.10.02 is not a neighbor, you get that address as a next hop because the neighbor 10.10.01 is in same subnet. Yeah.